Okay, let's get started with Chapter 5, and so we'll start with 5.1, which is modeling data with quadratic functions. So here's what we'll learn. We'll learn to identify quadratic functions and their graphs, and then given some data, we'll learn to turn that data into quadratic functions. So some vocabulary coming your way: quadratic function, standard form of a quadratic function, parabola, axis of symmetry, and vertex of a parabola. So those 5 are the vocab phrases that you're going to need to make sure you understand for 5.1. Alright, so before we get started, a couple skills we'll need for this section. So evaluate each function for -3, -1, 0, 1, and 3. I'll do one for you. So for number 1, we'll make a t-table. It's probably the best way to do this. And we'll have -3, -1, 0, 1, and 3. And for all of these, we're going to just have x be our output. So this one's easy. It's -3, -1, 0, 1, and 3. And maybe I should do 2 as well, just to make sure we can clearly see what's going on. Our x's are still -3, -1, 0, 1, and 3. Our y's then are -3 squared. So 9. -1 squared is 1. 0 squared is 0, 1 squared is 1, and 3 squared is 9. All right? And then 7, 8, and 9, we need to get this into slope-intercept form. Remember that slope-intercept form is y equals mx plus b. So we need to get y by itself for number 7. 3x plus 4y equals 8. And so we can move this around. We can minus the 3x first. So we'll have 4y equals -3x plus 8. And then let's divide everything by 4. So we'll get -3 over 4x plus 8 divided by 4, which is 2. So that's 7. Pause the video. See if you can do 8 and 9, as well as the remaining problems 3 through 6. Get those done, and then press play, and we'll keep going. All right, objective 1, we want to be able to understand and use quadratic functions and their graphs. So, what is a quadratic function? A quadratic function is any function that can be written in ax squared plus bx plus c. Now, this is the standard form. Standard form is when we're in nice order. We've got squared first, then x to the first, and then our constants. Okay, but if this was out of order, we had bx first, and then we had ax squared, and then c, or maybe c came first, it's still a quadratic function. It's a quadratic function if the biggest exponent we can find is 2. All right, so again, here's the standard form in order: x squared, then bx, then plus c. All right, and in this one, a can't be 0, because then it would go away, and we wouldn't have x squared anymore, so we would no longer be a quadratic. It's okay if b is 0 or c is 0. You don't have to have an x. You don't have to have a constant. As long as you have x squared, you're going to be a quadratic. And no x cubed. Can't be bigger than x squared. X squared has got to be your biggest exponent. All right, I think we've got that. Let's move on into classifying these. Determine whether each function is linear or quadratic. Identify the quadratic, linear, and constant terms. So here we go. We start with this problem. We could FOIL this, and right away I know that this actually is going to be quadratic, because how many x's do we see? I see 1, I see another one, so x squared is what we're going to end up with, so it's going to be quadratic. If we FOILed this, here we go. First, 2x times x is 2x squared, outside -8x, inside 3x, and last -12. Clean up the middle here, -8 plus 3 is -5, and so we do have a quadratic. 2x squared is the quadratic term. -5x is the linear, and -12 is the constant term. Remember, the signs come with us. Okay, so positive. We could have written a positive in front of the 2x squared. Don't need to write the positive. Definitely have to write the negative. All right, let's see what happens here. Let's distribute 3x squared minus 6x minus 3x squared plus 6. Don't forget to distribute that negative. What happens to our 3x squareds? They cancel, and so we're left with -6x plus 6. This is linear because it's just x to the first here. So no quadratic term, but there is a linear term, -6x, keeping the negative. And our constant is 6. All right, so your turn. See if you can do the same thing with a, b, and c. Tell me whether they're linear or quadratic, and then identify each of the terms. All right, so let's look at the different pieces of a quadratic. All right, the graph of a quadratic function turns into a parabola. So if we graph x squared, we get a parabolic shape, okay, the nice U shape here. So the first thing we have here is the axis of symmetry. Now, any parabola is going to be symmetric, meaning it mirrors itself to the left and right. The axis of symmetry is right down the middle. Where would we have to fold the paper so that we would get a perfect mirror? So in this case, the axis of symmetry is the line x equals 0. All right, it's going right through the middle. The vertex of a parabola is the point at the base, the bottom, or in this case, the top. Here's the bottom, right? So it's 0, 0 in both cases here. It doesn't have to be. All right? And then the y value at the vertex, the height at the vertex, is either the maximum or the minimum, depending on if we're pointed down, this thing has a top, so it has a maximum. If it's a u pointing up, it has a bottom, so it has a minimum value, and it'll be the y. All right? And that's all we need from this section. So here we go, example 2. We've got this equation graphed here. It's already graphed for us. Identify the vertex and the axis of symmetry, and then identify points corresponding to P and Q. All right, axis of symmetry is the line going right down the middle. It goes through the vertex. All right, looks like right here we hit 2 on the x-axis. So we're just going to say x is equal to 2. Remember, vertical lines have x equals as their equation. All right, P is 1, 2, so that's right here. So P prime would be on the other side. This is 1 to the left of the axis of symmetry. So 1 to the left of x equals 2. This will have to be 1 to the right. So 2 plus 1 turns into 3. The height stays the same, so the y value stays with 2. 1 and 3, 2 and 2 stays the same. All right. I think we skipped the vertex. It asked us to identify it, but it didn't say what it... Oh, there it is, sorry. Skipped her head at the top. Vertex is 2, 0. That's the bottom here. Is that a max or a min? If you said that's a minimum, good job. That's at the bottom of the parabola. All right, and then Q is 0, 8. That's 2 to the left of the line of symmetry. So Q prime would have to be 2 to the right of the line of symmetry. So that takes us over to 4, and the height is 8. So 4, 8. Your turn. See if you can answer those type of questions for A and B. All right, second objective here is we're going to use quadratic models, and for this you're going to need your graphing calculators. So grab your graphing calculators out, get them ready to go. I'm going to bring up mine here, and so we are going to find a quadratic function to model the values in the table. So we've got some numbers given to us, just 3 different points. We're going to figure out what the parabola is that goes through those 3 points. So here's how we do it. Follow along on your calculator. This is a list of numbers. Okay, so we want to put them in a list, and where that is it's in stat. It's in the statistics. Okay, so in here we want to go edit our stats. So we'll go in here and look at the top here. L1, 2, 3, 4. All these stands for list. Okay, I'm going to clear these out. To clear something, sometimes it's confusing. You have to go up to the top here, hit clear, and then hit enter, and your whole list will go away. Go up to the top, clear, and enter. Clear and enter, clear and enter. And for now, you can do lots of crazy math stuff with these things, but for now, make sure you're always entering your number in L1 and L2. Okay, first list and second list. So here's my numbers. My x's will go in L1, 2, 3, and 4. I'll move over and put my y values in list 2, 3, 13, and 29. All right, make sure you can get to this step. You might have to pause the video to catch up, but make sure your L1 and L2 look like this. I hit stat and then edit to get here. All right, if you're ready, now we need to do stuff with these. So first, it doesn't ask us to, but I'm going to graph this first, okay? Because we're going to need to do that also. So before I graph it, I want to find out what's an appropriate window here. Where do I want to look? So what's our range here? What's our smallest x? Our smallest x is 2. So our x min, we want to go a little bit smaller than 2. So how about 1? Our x max is 4. We want to go a little bit bigger than 4. So I could say 5. I could say 0 and 10 if I wanted to. A little bit below, a little bit above. Let's talk about the y's. What's a little bit below 3? How about 0? What's a little bit above 29? How about 35? Okay. Now if I hit graph, I know I'm in the right spot. And here comes, oh, I forgot to do something very important. So I have these numbers put in my stat, in my lists. Okay, but I'm not telling my calculator to graph them until I say turn my plot on. Okay, so plot up here plots numbers that you've stored in your lists. So I go up to that, I hit enter, and now you'll see that plot is highlighted. Now I hit graph, and there's those 3 dots. Now it doesn't look like a parabola, right, because we don't have the curve coming down through it yet. All right, we're going to do that. We're going to let the calculator come up with it for us. So here we go. We're going to go back to stat, where all our numbers are, and we're going to do a calculation with those. Okay, so entering in the list was in edit. Over here, we're going to do a linear regression. We're going to let the calculator, I'm sorry, we don't want linear. This is quadratic. We want to do a quadratic regression. We want the calculator to figure out the equation for us. So we go to that, we hit enter. Okay, and your screen might look different than mine at this point, but what you want to do is make sure you calculate it. And so I've got 3, -5, and 1 for my A, B, and C. 3, -5, and 1. So I can now go graph this as 3x squared -5x plus 1, right? My numbers were 3, -5, and 1. A, x squared, b, x plus c. Remember, this is standard form. And so now I've got an equation for the whole parabola. I still have plot 1 highlighted here, so it's still going to show my 3 points. Now if I go back and graph it, here comes, oh, look at that thing of beauty. Okay, the curve's going through it. I'm going to expand my window here, and I'm going to say -10 to 10 for my x's, just to expand a little bit. And look at that. There's a beautiful parabola coming right down through there. All right? So, your turn. See if you can make the same thing happen for these 3 points. Follow the same steps. And if you get confused, we're going to do it again here for example 4. But do the best you can. Try to get an equation and graph the line that goes, or I'm sorry, the quadratic that goes through those 3 points. All right, let's do it again. We want to have this table here showing us the height of water as it drains from your jar here. Let's model this with a quadratic function and then graph the data. Use the model to and then estimate the water level at 35 seconds. So one extra step here. All right, here we go. Let's go into our calculator. Go back into our list. We're going to edit this. I'm going to clear out my lists. So go up to the top, hit clear. Top of L1, clear and enter. And here we go. It's every 10. 0, 10, 20, 30, 40, 50, and 60. And then the, oops, I gotta hit enter. And the Y numbers aren't quite as convenient. 120, 100, 83, 66, 50, 37, and 28. All right, that's my list. Let's go ahead and set up my window range for this. -10 to, how about we go with 70 on this one, right? A little bit below 0, a little bit above 60, a little bit above 120. So look at this, this is a little confusing. It's going down, so our smallest number is 28, so we want to be a little below 28. So how about 20? A little above 120, so how about 130? Go ahead and turn our plot on. I'm going to clear out our old quadratic. We don't want that one from the last problem. And graph this. There's my points. You can see how they're starting to curve down. Okay, this is not a straight line. Straight line would be, you know, coming down like this. This is curving, so curve is going to be quadratic. Let's go get our equation. So we're going to go over in stat, go over to calc, calculate, and we want a quadratic regression. By the way, on these, if I just hit the number 5, it'll go straight to quadratic regression. Okay, hit enter. There are my numbers, so 0.009, -2.1, and 120. And let's see here. See if I can remember these 3 numbers. 0.009 x squared. Nope, I've already forgotten them. There it is, negative 2.104. X, and what was my last one? Second quit takes me back to the main screen here. 120.333. And if I got those numbers down right, if I graph it, this curve should go right through all these dots. Look at that. That's a thing of beauty. Okay, so we've got that nice curve. If I expanded my window here, so let's make our x's a lot bigger, maybe 200 here. We could see the curve come back up. Looks like I need to have my y min go down a little lower as well, about negative 50. So we can go below the line. Are we going to see the vertex? Yep, there it is. It's starting to curve back up. All right, so we've got this equation. And now the last step is, so I'm sorry, we got an equation. We've got a nice graph. We want to use the model to estimate the water level at 35 seconds. And here's the last really awesome thing the calculator can do for you, and that's the table function. For this equation, we're going to go in here to table set. I hit second first and then window, so I want table set in blue here. I want to have my calculator plug in numbers starting at 35 and counting doesn't really matter because I only want 35. But what if I wanted to know 35 and 36 and 37 and 38? I could count by ones. Once I've set up my table, I'm going to go into the table, so second graph, table right here. If x is 35, y, now y1, notice y1 is coming from this equation we plugged in. y1 is 57.718. After 36 seconds, there'd be 56. After 37, there'd be 54.8. Okay, so it's doing the calculations for you. This is 57.7 is what we would get if we plug 35 in for x and for x into this equation. It would spit that number out. So there you go. You need to try number 4. Make sure you can do this, and that's all there is to 5.1. Good luck. If you need help with the calculator, make sure we go over it in class tomorrow.